Assalamualaikum and good morning to everybody. Welcome back to our class BAA4273 Earthquake and Wind Engineering. Today I will discuss about topic 2, which is about the ground motion records and the design response spectrum. So let me present my screen to all of you. In this topic, I will discuss about the ground motion records from real earthquake and the nation seismic hazard maps. This is for part number 1, which is discussed in this video, and the design response spectrum will be discussed in another video, which is in part 2. What you have to know about the ground motion records is about the propagations of energy waves. It divided into two types of earthquake, which is the first one is far field earthquake. The first one is the far field earthquake, and then the second one is the near field earthquake. According to the researchers, the far field earthquake is any earthquake recorded beyond 50 kilometers from the fault, or some researchers mention that it must be beyond 20 kilometers from the fault. And as contra, the near field earthquake is any earthquake recorded less than 50 kilometers from the fault. It can be divided into three types, which is the forward directivity effect, backward directivity effect, and the fling step. Okay, as you can see, this is the fault. This is the epicenter of the earthquake, or the focus, and then this is the site of the recorded earthquake. If the rupture is propagated toward the site, we call it as the forward directivity effect. However, if the rupture is propagated towards the site, we call it as the backward directivity effect. How about the fling step? Okay, the fling step is the fling step is any ground motions which cause permanent displacement to the ground surface. This is related to tectonic deformation, which is strongly influenced by the rupture mechanism. Okay, this is the difference between the ground motion records of the far field earthquake, near field earthquake with forward directivity effect, and then the near field earthquake with the fling step. We can see here, this is the velocity against the period, okay, and then this is the displacements against the period. The forward directivity effect, the displacement, the velocity is almost maintained along the period. However, for the near field earthquake with forward directivity effect, we can see a sudden increase on the velocity, which we call as the pulse. And for the near field earthquake with fling step, the ground will have permanent displacement after the earthquake. Okay, and this is the examples of single ground motion records. Okay, this is the accelerations over the periods. Okay, this record are lasting for 30 seconds, 50 seconds, and this one is for 90 seconds. Okay, we can see that the sudden increase in the acceleration here, also here. And this is the example of recorded ground motions from the multiple earthquake. Okay, this is we call it as the foreshock. Okay, before the main event. This is the main shock. Okay, after several seconds. Okay, let's say after several time of zero accelerations, and then the second, okay, the second shock, which is the main shock, occur, and then it will stop before the following shock occur, which we call it as the aftershock. Okay, this is the example of selected near-field earthquake ground motion records recorded on soil type B. Okay, this is the code, the name of earthquake, the recording stations, the magnitude, and then this is the distance from the fault. And then this is for far-field earthquake recorded on soil type B, which is recorded beyond 50 kilometers from the fault. And this is the seismic hazard maps around the world. It shows the seismic intensity of particular regions, and it is in form of reference peak ground accelerations. We will use these symbols later in the developing of design response spectrum, which I will talk about this one in part 2 of our lesson. Okay, and the unit is GAL in US, and in gravity in the metric units. Okay, this is the seismic hazard maps for Malaysia from 2009 until 2017, before the latest one, the revised one, which we can find in the National Annex. Okay, we can see here that in Peninsular Malaysia, the range is increased from 20 gals up to 100 gals, which is increased from the east part of peninsula to the eastern part, to the western part of the peninsula. And the 1 gals is equal to how many G? How to convert the unit of gals to gravity. So 100 gals is 1 gals is equal to 0.001 G. So let's say if this area is 80 gals, so means we have to divide by, you have to multiply by 0.001 G. So it equal to 0.08 G. Okay, and this is for East Malaysia, where the seismic intensity increased from 60 gals to 120 gals, and the highest is in eastern part of Sabah. However, this map is only valid up to 2017, before the latest one supersede the previous one. Okay, and this is we can find this map in Malaysian National Annex to Eurocode 8, published officially in December 2017. So this is the latest intensity in form of contour here. If we can see, this is the unit is in form of percentage of G. So if your site of interest is here, 7 means 7% of G, or equal to 0.07 G. Okay, if your site of interest is here, which is, okay, this is 5% of G, so your alpha GR is equal, your reference peak ground accelerations is equal to 0.05 G. Okay, and this one is for Sarawak. If your site of interest is here, which is near the Miri, let's say So you can find the value through the contour here. It's 6%. Okay, alpha GR is equal to 6% of G. So it's equal to 0.06 G. For this one is for Sabah. We can see that the highest intensity of seismic is in Ranau area and also in the Lahad Datu. Let's say you have your site in Ranau, you can see the number is 16, means the alpha GR there is equal to 16% of G or equal to 0.16 G. Okay, let's say in near the Pensiangan here, you have 5, means 5% of G or equal to 0.05 G. Okay, that's how we interpret the seismic hazard map of Malaysia. Okay, that's all for this part. Thank you very much for your attention. In the next part, I will discuss about the design response spectrum based on Eurocode 8, the type 1 and type 2 design response spectrum, and then the salt type based on the Eurocode 8 and Malaysia National Annex. So, all the best for all of you. See you in next video. Bye-bye.